So we are going to continue in English the second part of this, let's say, open day of this, the DOMUS demonstration of the and validation of the U.S.-based concept. So welcome again to you all, and also to those that are following us just by streaming and internet. So in this second part, we are going to proceed with additional 2 trials. The first trials, it will come immediately. It will be tactical deconfliction combined with a collaborative interface with ATM. So we will see the way that US space can interact with manned aviation, and in particular, interact and interoperate with ATM from a digital perspective on a collaborative way. And we will proceed after that, right after, just to our third trial. And in the third trial, we will have an urban demonstration. So as you know, that part of the SESAR project, or the SESAR JU objectives within this call, was to proceed with a rural, semi-urban, or suburban and urban demonstration. So that's why we have this myriad of trials, and of course with at least 5 drones flying, and with multiple, that's the option we went for, with the option of playing or managing multiple providers of US space. So let's go to start with this second trial. So Danny, floor is yours. Thank you.
Okay. So welcome everyone. We have new people here from 11 o'clock in this second block. And we're going to the step 0, to the presentation of the trial 2. And in this case, as we did before, we are going to tell in advance a little bit what are going to see. But then we are going to see all that parts in detail. We are going to have, with the company SESAR, okay, we are going to have a fixed wing flying that is going to have an interaction with a manned aircraft, okay? A manned aircraft, as you can see in this drawing, we are going to have CATEC operating in the Upper West in a controlled airspace that is going to need a flight plan manual approval by the air traffic controller. We are going to have an air traffic controller that I haven't said that yet, and it's going to be in ENAIRE building. Okay, we are going to connect with him later, and we are going to see the interaction with the air traffic system, the ATM system, in live. And then we are going to have again, as the trial 1, an emergency area, and interaction with, again, with the recreational flight and the ATC corridor that is going to be created by the air traffic controller into the system, directly from the air traffic system. So now, step by step, if you remember, we had the strategic deconfliction, that if you do a flight plan request and there is other flight plan already filed, you have an alternative, okay? The ecosystem manager provides you an alternative. But what happens if this is a priority flight plan? What happens in the drone in the left side has a priority flight plan? But then it's the other drone that we have to land, because the left one has priority, okay, in a case of emergency. In case of the collaborative ATC, imagine that you have a drone operating. The air traffic control needs an area that has to be free of drones. He can create in his own system, okay, this is important, not in the ecosystem manager on the US space, not. In the air traffic system, he's going to create an area, and that area is going to be read by the ecosystem manager and the US space. And that information is going to be followed by all the pilots, all the drones. So, and he will have to land. What happened with a helicopter or unmanned aircraft flying? In this case, This is only a small circle, but in reality, the circle around the airplane, it's bigger, of course, is going to conflict with a drone that is flying, and he will have to land. Okay, this is, in other picture, the different systems, U1, the U2, U3, U4, that they were introduced this morning. In DOMUS, we remind that we have all the services of U1 and U2, and in this trial number 2, we are going to have the collaborative interface with ATC. So let's go. Let's go to the step 1. That we start with a pilot connecting to the USB ENAIRE, in this case, from the, in this case, is CATEC company. And we are going to remember how is the registration, okay, from people that didn't come in the first part. You have the information of registry with the pilots, information of the pilots, and the drones, okay? All the data that is needed, of the drone information and pilot information. And now we are going to see an example of weather information that we didn't see that before. In this case, there is a system, a weather system in Atlas that was installed by our partner Earth Networks, and we can see the real information of weather. Okay, this is a case of with the system can provide that information. And the other colors that you see is the NASAP. It's a module by GMB, and that's the GPS performance. If you want to know how is the GPS performance in that moment or in the future, they have the performance data of GPS in the future, and it says integrity, continuity, availability, etc. So that colors mean the different performance in GPS. So now we go to the step 2. And what we are going to see now is we are going to create 2 flight plans. We are going to create 2 flight plans, not for flying, but for interact with the ATM system. So in this case, we are going to, you can see a flight plan that is already filed from CATEC. In this case, the U.S.-based services is ENAIRE. You can see that example. And in the right side, you can see their map USB with the flight plan. And if we click in the flight plan details, this is the flight plan that it's already submitting. And again, these areas are not to be flying. It's going to be to have an interaction with the ATM system later. So just remember these flight plans. Okay, so now we're going to the step 4. And now the operator CATEC and the USP ENAIRE is going to do a mapping mission. And what you see there in orange, imagine that it's a CTR or an air controller space. So if your flight plan is inside an airspace area, he needs an approval by the ATC. Okay? Now has been approved. You can see it's manual. Manual, that means that needs an interaction with the traffic controller, okay? So until the traffic controller doesn't accept the flight plan, it will not change the status, okay? This is the Allende building. This is the traffic controller, Fernando. And this is the ecosystem manager, the interface, the ecosystem manager with ATM. So he can see now the flight plan. He sees the same information than on the left side. He's checking the flight plan. So So it's already planned, okay? It has changed. The color now, you can see that it's green. But did you see the status has to be now in planned? And by the way, we have already the airplane prepared for later. Okay? So, okay. I think I will go to the next step. We're going to the step 5. Let's change the view. Okay. What we are seeing now, that's not the plane, okay? That is the fixed wing from SESAR. That he has already taken off is a fixed wing. And this is what you see now, here. No, it wasn't the plane, sorry. It was this. That has already taken off for the next exercise. So I would like to see in ENAIRE building the manned aircraft in the radar, okay? Si podéis conectar con ENAIRE, ¿vale? Okay, that's the airplane that we'll see when it's closer to the Atlas. We'll see the airplane. And now we can see the transponder code, the 7224. And that information is sent, as you can see, to the left side, to the traffic information in U-space. Okay? He's not generating any alarm because the plane is above the very low level limit. If the plane goes down the very low level limit, it's going to generate alarm to the drones that are in that part. Okay? The very low level limit is not set in this demo in 400 or 500 feet because it's very low for an airplane. We have put higher, more or less 1,500 feet for safety reasons to the airplane. Okay, so now we can see the U3 service, okay, the U3 U-Space services of information of the airplane to the U-Space and the drone into the ATM. Okay, so this drone can be seen or not seen. You can select if you want, you can filter if you want that information or not, or only if there is an alarm. Because an air traffic controller, you cannot put a lot of information, only if there is an alarm. But in this case, okay, is to show that there is a perfectly information between the two systems, okay? Perfect. So now I think that the plane, you can say to the plane that they can go to the point Bravo to later do an exercise. And we go to the, now we are going to connect with Galicia, with the Ancora Center. So this is in Galicia, Northwest. And what we want to test here, or to demonstrate, is this is not a system-only regional system. This is a national-wide system. If you are connected to internet, you can send your telemetry, you can be wherever you want, and you will see it, even worldwide, okay? So we've been lucky that it's not raining in Galicia. And after the taking off, we have to see the information in the traffic information service. There is any alarm. If we zoom, we will see the flight plan. That is that area. That is in blue. It's inside the flight plan. There is no alarm. Okay? So thank you to Galicia. We connect again to Atlas in the step 7. And now we are going to begin with more taking off of drones to complicate the demonstration. This is a fixed wing that is already flying. Remember, in the right side. Okay. This is the matrix from CATEC. The U-Space service provider is Indra, with a mapping mission. And I would like to see in the left screen the blind tracks of other drones. This is important. The difference between the traffic information of U-Space in the ecosystem manager and the information that has an operator is this screen. You have to think that this is the screen of the operator, okay? That is Indra. And they have no information. In this case, the operator wouldn't have any information about the other drone, only the position, okay? So that's the difference between the information of an operator and the information you have in the traffic information in the U-Space, okay? That you don't have all the information. So now let's go to other pilot, in this case, INECO, in the ENAIRE U-Space services. In this case, with a flight plan, okay? In this case, INECO is going to file a flight plan, a recreational flight. Now it's been creating, and that's the area that is going to be the drone. Okay. Okay, and we will see the information later. Okay, when the GPS synchronizes correctly. That dongling specifically, sometimes it takes a bit to synchronize the GPS. So, well, now let's go to put the things interesting, and let's start with emergency situations. We have 3 drones on flight. The right side, the fixed wing, the matrice in the north of the runway, and the drone of INECO that we will see later here, more or less. Okay? So imagine that we have a car accident, and there is no authorities there. So in this case, instead of Guardia Civil that creates an area, it can be done remotely from an emergency control center, for example, in Madrid, or whatever. And we can see here how is being created the area by GMB, emergency management, and immediately it's sent that area to the U-Space, okay? And it's registered and is known by all pilots, okay? So now going to the step number 10. What does it mean? Now this is the screen of the operators, different operators. The only operator that has an alarm is this one, because the emergency area has been put over its flight plan. But as you can see, the other operators, they don't have any alarm because they are not affected, okay? By the way, that is the ground control station of the information of the fixed wing, where you can see the altitude, the speed, etc. Okay, so now we are going to the step 11, that the matrice of Qatar is going to create a geofence alert. It's going to get into the emergency area, and we are going to see new alarms. He's having now an alarm of tactical because of the flight plan, but let's see what happens when he gets inside the emergency area. there are new alarms of geofence. Okay, we have different alarms. We have alarms with flight plans that is emergency, or if you are inside an alert, you have other alarms too. And now we have even the orange alarm that, if you remember, was when you are outside your flight plan. So all the alarms are functioning correctly, okay? Are perfectly so. He can go again, now he's going to land, going to the step 12, and later to the step 13. But now he's going to lag the CATEC, and we are going to do an strategic deconfliction with the geofence. Okay, that I'm going to explain that because it's an important US-based service. So we are going to see now, this was the original flight plan, but now we have that emergency area. But now the USP, okay, the USP service provider, if you remember the schema of DOMUS, is not going to be done the strategic deconfliction by the ecosystem manager. No, it's going to be done by the USP service provider. This is a proof that the USP service provider can provide different services to the operator, added value, okay? A USP service provider cannot deconflict with other flight plans if they don't have the information. But if they have geofence information and not an information, of course they can do that strategic deconfliction. So in this case, the deconfliction is going to be done locally by the USP service provider. Now, has landed the drone. That's the INECO, the recreational flight. And now let's try to the flight plan to do let's do the strategic deconfliction. Well, it says that it has flight plan has conflicts because maybe we have to wait to refresh the information, okay? So that's the area he's going to do the deconfliction, okay? Now he's doing the authorization, and now it's planned, okay? Now, later, the drone is going to take off. We are not going to focus in that, okay, to go more faster. And now he's prepared to fly without affecting to the emergency area. So we go to the step 14. In this case, it's something similar to the use case that we saw in the first trial. He goes to do, in this case, is going to access to the emergency area with a priority flight plan again. But in this case, the important thing is that the priority flight plan from Correos that is going to be to the right side is going to affect to the recreational flight. That's the idea, okay? So in this case, INECO is going to be affected by this flight plan, and he will have to land, okay? So when he's prepared the flight plan of Correos, we have to go now to if it's already filed, let's go to the step 15 to see what is the information that INECO is receiving, okay? INECO has already received the information that there is a new flight plan that has been affected. You can see, instead of this one, let's see the left side, okay? If the sound, I don't know if it's possible to put the sound of the camera, but that's the sound of it's very important because when you are flying, you don't have the mobile in front of you. But if it starts to beep, it's very important that there is something that is affecting to your flight. So okay, perfect. So now in the step 16, the Correos drone with the operator Fubex is going to take off, and he's going to go to the emergency area.
ENAIRE para INECO, apagar el bloque. Ok, apagando dongle. ¿Funciona todo? ¿No lo crees? Bueno, tenía que ponerse en rojo, pero bueno.
We don't have information of INECO because it has already landed. And he enters again in the emergency area with no alarms because it has a priority flight plan, okay, as the trial one. But in this case, it has affected two other drones, okay? That was the important trial, the important test, sorry. So perfect. So well, let's put in play now the ATC, and let's go to the step 17. That now Fernando, our air traffic controller, is going to create an area, okay, an ATC area from the ATM system. Okay, this is the air traffic control system of ENAIRE. That's the area he's going to create. It can be drawn immediately, or in this case, we want it to be perfectly drawing, okay? And now he's going to load it and to send it. Fantastic, it's there, okay? In the left side. That's the ATC area created by the air traffic controller from his system, okay? So we can see again the communication between the ATM and the U-space. And now let's remember the flight plans that we did in the beginning. Do you remember them? Now they changed the status. They have planned, but now they have a different color. That means that the status is manual. So the operators now they have that flight plans in manual status. That means that they need an air traffic controller approval, okay? Manual approval. Okay. Si me clicáis, que se pueda ver el... Ahí están. Okay. There is. These are the flight plans that previously was planned, and now it changed the status to manual because they have been affected by the air traffic area. Okay? So perfect. Now let's go to the curious step, the step 19 with the manned aircraft. Okay. Now what we are going to test is if the plane goes above the very low level limit that we have put, they won't have, the drones shouldn't have any alarm, okay? So the plane is going to fly from the left side to the right side. If he's flying below the very low level limit that we have set in 150 feet, more or less, there will be alarms. This is very important, this part, especially for helicopters, because the planes usually fly above 1,000 feet. But in case of helicopters, they usually go below, or it's very often to go below 1,000 feet. So in this case, we have some issues with drones, for example. And we don't have, this is important, we don't have information of the plane in the traffic system because we don't have now, because of the altitude, radar coverage. So this is important because this can be used as extended information for traffic control too, in case of manned aircraft that goes below radar coverage. Okay. So now it's not generating any alarm. If there was any alarm, the drones will have red color. Okay? That meant that they were receiving alarms. So now, Eduardo, you can transmit, I think that the plane already can prepare to go below the very low level limit. Okay. A very nice day. This last weekend wasn't the same. And we were there. So we've been lucky. So now the plane is preparing to turn and go below this very low level limit. That means that the plane already is below the very low level limit. And they are receiving the alerts because for this demonstration, we have put a very huge area, but that area can be adjusted by, for example, the speed. That area can be adjusted by speed. If you move faster, you can put the area bigger, okay? But in this case, we have put a bigger area to don't have any trouble, any problem, safety problems with drones and for testing the service. So we can see the alerts on the left side, okay? The operators, the 3 operators are now receiving in the system these alerts of a manned aircraft, okay? So if we go to the step 20, we are going to see an example, in this case from the SER, that is now there. And you can see what is the message that he's receiving. You must finalize mission safety. He's not saying that it's become the airplane, okay? But he has received that they have to finalize the mission because of the airplane. So perfect so far. Let's go then to the step 21. Okay, we're finishing this live demo. That now, this has been, I think, this is a good example of coordination in an emergency situation between drones and unmanned aircrafts, okay? So remember that we have now an airplane that could be a helicopter that would land in the emergency area, and remember the Correos drone that is being in the same area in emergency situation. So I think this is an important test that this can be done to have flights at the same time, manned aircrafts and drones. So, and we need this system. We need this system to do this kind of thing. So we can see the airplane. So perfect. So for finishing this trial, that is longer than before, we go to the step 22. But we need first, I think, that the airplane elevates the flight level, okay? because all the drones are red, still red because of the aircraft. ¿Se le ha dicho que suba el avión? Sí, vale. So we are going to wait until the airplane is again above the very low level limit and stops the alarms. Because now we have to create a new alarm, the last one. Okay, so they have done the loss of link situation. Okay, this was the last part, the step 22, with the data leak interruption of the ground control station with the drone. It has been done in a very short time for security reasons, but now we are going to see in the step 23 the message when we lost the loss of link, an example of message that there is a drone near you that has a loss of link, that has suffered a loss of link. Okay, so the drone operators that are around that drone receive that message, so they can or continue flying if they see if they can see, or for safety reasons to land. So we go to the step 26 now. We have finished this trial related to all these flights. And we are going to see, only to say goodbye to the people from Galicia. Okay, and now to the step 27, to say goodbye to people from Atlas now. Okay. Although there are a lot of more people, okay, but there is no time to gather everyone. But there are like 20 or 30 people there, okay? So now let's go to the presentation again to finish. The step 0, the PowerPoint, please. So we are going to go fast again. This is all the cases that we have seen. I think maybe it's a little more difficult to digest, no, this trial, because there are huge information. But I think that the important thing is to see that the system is that connects to the manned aircraft, to helicopters, and has interaction with air traffic control. I think that is the most important thing. I'm going to go, and again, I'm going to show an example of what is a message that is receiving what is a manned aircraft close to the pilot, to a drone operator, or where is a loss of link, okay? That is, in this case, was CATEC operator on the left side lost the connection with the ground control station, and the alerts was received by the operators FUBEX and SESAR, okay, in the red one with that messages, okay, and even in echo. So that's it, and this is the end of the second trial. Thank you.